Welcome. We are going to learn about the Kepler's laws, also the heliocentric model, geocentric model of very important phenomena of universe. About the geocentric model. Now, what is geocentric model? Geo means earth, centric means center. We can see here. Now, I will play a video comparison between the geocentric and heliocentric model. So, in geocentric model, it was proposed by Ptolemy. Ptolemy proposed that Earth is at the center of the universe, all other planets including Sun. We can see the first picture where all the planets including Sun revolving around the Earth. So, this is the geocentric model proposed by Ptolemy, which was in belief for the more than 400 years before BC, and then even after AD up to Copernicus period, nearly 2000 years people used to believe the concept of geocentric theory proposed by Ptolemaic system of the concept of the universe, but it was contradicted by the famous astronomer Nicolaus Copernicus, which we popularly known as heliocentric. We can see the second video now. The heliocentric model, helio means sun, centric means at the center of the universe. Sun is at the center of the universe, all other planets revolve around the sun in an elliptical orbit. So, you can see here now. So, the first planet is Mercury, then second one is Venus, third one is Earth, fourth one is Mars, like that Jupiter, Saturn, Uranus, Neptune, Pluto, which we are talking about now. This is the solar system conceived by the Copernican system. See, Copernicus, this theory was proposed in the year 1543. Later, many of the scientists, they used this heliocentric model to explain various concepts in the universe. You can see between Mars and Jupiter lot of debris are being flying. This we call it as asteroid belt, and around the Saturn we can see number of Saturn rings are present, and the highest number of moons are present for Saturn, and next number of moons were for Jupiter. So, these are the this is the idea conceived by Nicolaus Copernicus on heliocentric model. These are the two models that exist previously, but many of the scientists after Copernicus they want to establish a phenomena supporting the Copernican concept of heliocentric model. Now, the learning objectives of this main program is the Tycho Brahe and Johannes Kepler, how they worked to prove this heliocentric model, and then to understand the concept of ellipse such as focus, semi-major axis, semi-minor axis, eccentricity, and also the perihelion, ephelion, and the eccentricity value, how does it affect the path of the planets around the sun. These are the, and also the three laws of Kepler we are going to discuss in detail. These are the learning objectives of this lesson. We will go to the actual heliocentric model. Heliocentric model is set down by the Copernicus. The basic concept is sun is at the center of the universe. Later this was proved by Galileo by observing through telescope along with other scientists, and the scientist the Tycho Brahe worked on with the mathematics rather than observing through telescope. Then around 1610 Galileo gave an observational evidence of based off the telescope. First he observed the moons of the Jupiter, and that has given a clear evidence of an object orbiting around the another object. Second one is the phases of Venus. Like moon, the Venus also has some phases, and sunspots. We can see once in 11 years the sunspots will increase. As the number of sunspots increases, that will cause rain on the earth. So the rains and sunspots are interlinked. The more the sunspots, more the rain, and less the sunspots, less the rain. So these sunspots also gave clear evidence that heavens are not perfect. Craters and mountains on the moon gave clear evidence that the moon is another world. You can see some of the pictures recorded by the Galileo, that from February 28th to May 22nd, the phases of the moon, there we call it as a crescents of the moon. Why they are occurring? These are the strong substantial evidences given by Galileo. Galileo's sunspot drawings. Galileo has drawn number of sunspots. We can see here the black dots on the sun. These are the sunspots identified by the Galileo after a long observation, and the maximum period of sunspots he observed during certain period, and more importantly show that surface is not perfect. It has a number of cold areas which we call them as sunspots. In the 1609, Galileo first observed space through telescope, and the same year Johannes Kepler published a book called Astronomia Nova, in which this book he proposed the three laws of Kepler, keeping in view the importance of this 1609. 2009 is declared as year of astronomy. So internationally we observe that 2009 is year of astronomy. Don't look at our food, look at the universe, which is amazing. Lot of things are present in this universe. Next is Tycho Brahe. Tycho Brahe is a scientist who believed that a number of calculations, and he wanted to support geocentric model, whereas Tycho Brahe wanted to establish his own model of concept of universe, and whereas Kepler was taken as an assistant to have a mathematical support, because Tycho Brahe is not well versed with the mathematical concepts. So he adopted Kepler as assistant to calculate mathematical concepts. Now we can see the concept of ellipse, which is very important to explain Kepler's laws. Every ellipse has two focuses, we can see f and f dash. There are two axes for the ellipse, they are called major axis and minor axis, and these two focuses we call them as foci. So in ellipse the eccentricity will be generally 1, and for circle the eccentricity will be 0, and for hyperbola the eccentricity will be greater than 1. Kepler's laws. There are three laws proposed by Kepler. The first law is called law of planetary orbits. The first law is called, Kepler's first law is law of planetary orbits. Every planet travel in elliptical orbits with the sun at one of the foci. You can see here in this, either sun is at f or f dash, and therefore this planet will follow elliptical path. The second law we call it as law of areas or law of conservation of angular momentum. Planets with larger orbits move slowly than planets with smaller orbits. The radius vector, which means, for example, if you say sun is at focus, the line joining the planet and the sun, we call it as a radius vector. This radius vector sweeps equal areas in equal intervals of time. So the area swept to the planet always remains constant. For example, in winter season the night may be longer and day may be shorter. In summer season day may be longer and night may be shorter, but total day will always be 24 hours. So this is 2 points. Another is called, one is perihelion, aphelion. The farthest distance from the sun we call it as perihelion, and the nearest distance we call it as aphelion. Third law, which we call it as law of orbiting planets. The square of the orbital period of the planets is directly proportional to cube of the semi-major axis. That is, if t is the period of revolution of a planet around the sun and capital R is the radius of the major axis, then we say mathematically t square is proportional to r cube. This is the mathematical relation for the Kepler's third law. So these are the three laws proposed by Kepler to explain the motion of planets around the sun, and this is perfectly established. The heliocentric model of Copernicus contradicting the geocentric model. So, whatever the theory now we believe is heliocentric model, all Kepler's laws strongly supported the Copernican concept of the present solar system, that is heliocentric model. Thank you.